Hello all. So welcome to the second week of this course on time series forecasting with applications in R. So before we start with anything in this week, I just like to give you a short overview of what do you expect in this second week going forward. So the first idea we'll discuss would be called as time series decomposition. So how exactly can we actually decompose any time series into its different components? And then we will try to introduce some really basic time series models to start with. So, let us say autoregressive or moving average or random walk, alright. And then of course, we will kind of end the week with again a practical session in R, alright. So, the initial idea is to describe what exactly we mean by time series decomposition. So, again as the name suggests, we will try to kind of decompose a particular time series into different components, alright. And again the idea is really easy. So, in front of you what you see are the 4 different components of any time series process yt. So, again just to keep the same notation in place, we will again use yt as the notation to describe the underlying time series, alright. And the underlying time series could be actually broken down, or it can be decomposed into all those 4 different parts or 4 different aspects, alright. Now, we will try to elaborate more on each and every component here. So, the first one probably many of you might already know is called as trend, or for that matter is called as secular trend. So, a more technical terminology is called as secular trend, and notation wise is called as TT. Okay. Now, again just to remember that the subscripts we are using, which are T, denote the timestamp. Okay. Alright. So, just to describe, the first component is called as secular trend. Now, moving on, the second component is called as seasonal component. Now, again as described in probably one of my earlier lectures, that seasonal component is such a component that sort of repeats after some time points, right, or you see a certain repetition in the seasonality aspect of the time series. Okay. So, the seasonal component is also called as seasonality in a more technical way. So, moving on, if we describe seasonality, or if we are saying that a time series process is seasonal, it kind of describes the second component here, which is the seasonal component, alright. Then moving on with the third component is called a cyclical component. So, again we will describe the difference between seasonality and cyclicality for that matter, but nevertheless the third important component is called a cyclical. And then the fourth component of any time series is called as random component or irregular component. Now, notation wise we can see that trend could be described as TT, then seasonality could be described as ST, then cyclical component can be described as CT, and lastly any random component or for that matter irregular component can be described by IT. Alright. So, now we will try to describe each and every components in a bit more detail, so as to understand that what goes inside a particular time series process, or what exactly a particular time series process is composed of. Okay. So, just to move a step ahead, so by the way, out of all the 4 components, the first 3, so TT, ST and CT, so trend, seasonality and cyclicality are called as a systematic components of any series. Now, again why systematic, you may ask? That systematic because these are completely due to some permanent causes and are predictable. So, again if you remember the Google stock price example or the Apple stock price example, or for that matter let us say any temperature data, right. So, what one can do is one can actually predict the Google stock price looking generally at the trend, isn't it. So, probably I will give you a small example. So, let us say if you have a hypothetical stock example, right, and you want to plot the stock price of that particular stock, alright. Now, looking at the general trend, one can actually roughly forecast it in the future. So, let us say the forecast might look like those, isn't it. Okay. So, I mean obviously if the data is available till here, then the forecast will not be suddenly here, right. So, just to try to understand this idea is that since you are observing a trend component, so the trend component can be predictable in nature. Okay. The same thing is true with let us say temperature data, or for that matter any seasonal data. So, how does a seasonal data look like? So, let us say you have repetitions. So, maybe something like that. Okay. Now, if one wants to forecast this in the future, then obviously the forecast may look like something like that, right. So, this is a very natural way to kind of postulate how the forecast may look like, Okay? And hence we say that the trend component, seasonality component, or for that matter cyclical component are systematic components of the series, and these are completely due to some permanent causes and also are predictable. Now, the remaining fourth component, which is the random component or the irregular component, is completely due to some noise in the data. All right. Now, if you remember vaguely, we discussed noise in one of the earlier lectures. So, what exactly is noise? Probably we will discuss again very briefly, that any noise is nothing but a combination of some entirely random fluctuations. So, let us say something like that. Okay. So, there is no pattern in the underlying noise, you do not see any particular repetitions in the noise data, right. So, the irregular component is not predictable for that matter, right. I mean, since all these data points or all these observations are completely random in nature, these are not predictable naturally, all right. All right. So, I think this slide describes all the four components. So, trend component, seasonal component, cyclical component and the random component in a bit more detail. So, if you talk about this first one, the secular trend component, which is denoted by TT. So, one can say that a trend component is a long term movement of a time series, right. So, hopefully this is clear, because if you want to describe any trend component, so trend does not happen in a really shorter time span, right. So, if you see a trend, hopefully the trend should last over a longer time span. So, we say that any trend component is a slightly long term movement of the underlying time series, all right. Now, how about the second one? So, seasonality. So, the seasonal variations or the ST component is again described as regular periodic variation, where the period of cycle is less than equal to 1 year. Okay. Now, again just to repeat this sentence one more time, is that the seasonal component denoted by ST, by the way, is any regular periodic variation where the period of the cycle should be less than equal to 1 year. Okay. Now, again if you take the most common example, which is let us say temperature data. So, how does temperature data look like? So, let us say there will be ups and downs depending on when there will be summers and when there will be winters. Okay. So, let us say let me write down temperature. So, temperature data at a particular location obviously over some time span. So, on the x axis you have time and on the y axis you have the underlying temperature. Okay. Now, let us say that these temperatures are monthly temperatures. So, let me add something here, that we are actually describing monthly temperature data. So, in this graph here, wherever you see peaks, for example, here or here or here, those would be summer months where the temperature is slightly higher, and wherever you see troughs, for example, here or here or here, those may be winter months. Okay. So, again here you see a clear repetition which happens over this entire time span at regular intervals. So, for example, June month or July month of a particular year, you might see peaks, and then let us say November or December or January for that matter, you might see troughs. And the same patterns repeated over let us say 5 years or 10 years or 15 years down the line. Okay. So, again going back to the definition, we can describe any seasonal variation to be a very regular periodic variation where period of cycle is less than equal to 1 year. So, here the period of cycle is in fact 1 year, because one can actually expect that the temperature which is there in June would roughly be the same in the next June, or the temperature which is there in November of a particular year would roughly be the same temperature in the next November, and so on. Okay. So, generally speaking, the repetition cycle or the period of the repetition or the period of the cycle is not more than 1 year. All right. Now, similarly talking about cyclical variations. So, what do you exactly mean by cyclical variations? So, any cyclical variations denoted by CT are any gradual and relatively long up and down movements of a series. Okay. So, any gradual and relatively long term up and down movements of a series. So, now looking at the definitions of seasonality and cyclicality, one can actually immediately write down a difference. So, what happens in seasonality? Seasonality, the period of the cycle or period of the repetition is less than equal to 1 year, but when it comes to cyclicality, the repetition cycle is naturally more than 1 year, and generally speaking majority of the times the repetition cycle is at least 2 years. Okay. So, obviously later on I will show you some particular examples, but just to describe the cyclicality idea in a bit more detail. So, let us say if you think of a simple example such as business cycle. So, cycle of any particular business for that matter. Now, obviously in business cycle what happens is whenever the business is in boom, so you can see a peak something like that, and then let us say whenever the business is not performing that well, you might see a trough, right. Now, again probably the next peak might not be as high as the one you saw earlier, right. And again obviously due to dynamic nature of the business, the next trough also need not be at the same length as earlier. So, this is a classic example of cyclicality. So, you see some repetitions, but these repetitions are not at regular intervals that you saw in seasonality. Alright. So, hopefully this definition of cyclicality and the difference between the cyclical component and the seasonal component is clear. So, again just to repeat one last time, seasonality there should be regular repetitions, whereas cyclicality you see repetitions but not regular, as you see here in this graph, right. So, depending on how the business performs, you can see a peak, and depending on when the business is not performing, you might see a trough, right. But again these lengths, so let us say from the recent peak to recent trough, and then again here, so recent peak to recent trough, again these lengths need not be exactly equal, alright. And now lastly talking about random variations. So, random variations again denoted by IT is purely random or irregular, and again as discussed earlier, so this kind of resembles the noise in the data also. So, random variations are such which are not predictable firstly, since it is a combination of completely random observations or random movements, right. So, there is no pattern there, there is no trend there, there is no seasonality there, or there is no cyclicality there, etc. Okay. So, again just to give you an overview really quickly, so the four components are trend, seasonality, cyclicality and random fluctuations or random variations, and a mix and match of all these four kind of constitute a particular time series process, alright. So, the next thing we will do is we will take up a small example. So, this example is called as a NOTAM data set, and then why NOTAM? So, what exactly this data set gives you? So, data set contains 20 years of monthly temperature measurements at the Nottingham Castle in the UK, alright. So, the time span is 20 years, and then the kind of the data is we are talking about monthly temperatures over the entire time span of 20 years. So, starting in 1920 up to 1940, and all these peaks or all these troughs that you see are nothing but monthly temperatures. Okay. Now, again as discussed a very short while back, that since this is a classic example of a temperature data, one would actually see some regular repetitions, right. So, in summer months the temperatures would be high, or in winter months the temperatures would be low. Okay. So, all these peaks here would be the corresponding summer months of those years, and all these troughs here would be corresponding winter months of those years. Okay. So, again I will say that this is a very classic example of seasonality. So, you have seasonality which is present here. So, in a way a time series decomposition exercise also tells the experimenter as to which component is dominant in that time series, right. So, I will ask you a very simple question. So, do you see any trend here? The answer is no, right. So, you only see repetitions. So, the data is not moving either upwards or downwards substantially, right. So, if you talk about trend being present, the answer is no. So, I will write down a cross, but is there a seasonality present? The answer is yes. Okay. So, for that matter which component dominates this time series? It is seasonality. Okay. So, through this exercise of time series decomposition, one can actually see that which component kind of dominates the underlying time series in an actual setting. Okay. Now, I will show you the decomposition of this same example in the next slide. So, this is exactly how the decomposition looks like. So, the top row is the actual data that you have. Then the second row kind of gives you how the seasonality progresses eventually, right. And here one can clearly see the peaks and the troughs in the data and can make out clear seasonality because you have regular repetitions happening over the entire time span. And then the third row kind of gives you the trend or the underlying trend, and obviously here one can see that the trend component is not at all strong because the underlying graph is not moving in one particular direction, right. So, again the trend is not present here, seasonality is very much dominant, and the fourth row kind of gives you the remainder. Alright. So, by the way, remainder is nothing but from a time series if you remove all the other components. So, let us say if you remove the trend aspect, or if you remove the seasonality aspect, or if you remove the cyclicality aspect, then whatever remains is called as a remainder. Okay. And again the fourth row kind of gives you the behavior of the remainder, and one can see that remainder is indeed completely random. Alright. So, this is a very simple exercise that should be performed at a very initial stage just to check as to which component kind of dominates a time series, whether it is trend or whether it is seasonality or whether it is cyclicality, etc. Alright. Now, probably what we will do is we will try to understand each and every component in a bit more detail. So, probably we will provide some examples also. Okay. So, the first component is trend. So, again just to give you the definition in short. So, any long term movement in a time series, so either upward or downward, is called as a trend. Okay. So, just to quickly chart some examples. So, let us say trend could be, let us say, upward, something like that, or one can actually have a downward trend, maybe something like that. Okay. So, either an upward movement or a downward movement constitutes a trend. Okay. Now, couple of sub parts. So, what exactly you mean by trend? If you break it down into further pieces, the first point is the trend does not contain any calendar related influences. So, let us say, so here one can't say that trend is upwards in summer or trend is downwards in winter, right. So, one can actually talk about a trend in a much more larger time span. So, either upward entirely or either downward entirely. Okay. And the second component is without any random movement. So, trend is predictable as we discussed earlier, right. So, just to summarize, so trend is without any calendar related influences and trend is also without any random movement. Now, just to understand this in a bit more easy way, so what exactly you mean by trend? So, trend is nothing but change in the mean level or change in the average level. Okay. And can you see that through both these graphs? So, let us say initially just think in your minds that the overall mean of the data would be somewhere here, right. But then as you progress down the line, as you progress down the timeline, the mean also keeps on changing. For example, then the average shifts here, then the next average might be here, and finally the next average of that sector might be here. Okay. So, can you see that the mean is also changing here, and similarly here. So, initially the average of all the close observations would be somewhere here, then the mean changes and let us say it comes down here and further down here, etc. Okay. So, any change in the mean level or any change in the average level is called as a trend. Alright. Now, the second important component is seasonality, okay, and then here we will discuss several examples which pertain to some seasonal aspect of a time series. Okay. So, let us say any seasonality could be described as any systematic or calendar related effect. Okay. So, we saw an example of temperature data. So, temperature data is also calendar related. So, summer months one sees higher temperatures and then winter months one sees lower temperatures, etc. Okay. But there could be many examples if you talk about seasonality. So, let us say higher sales during festive season. So, especially in India, if you talk about let us say Diwali season or Dussehra season, then people tend to buy more diyas or people tend to buy fireworks and so on, right. So, let us say higher sales of particular items during festive season, and largely because India is entirely dependent on the lunar calendar, right. So, whenever there are festivities, there will be higher sales of the corresponding items, okay. Or let us say higher water consumption during summer. So, again seasonality aspect is there. So, in summers there will be higher water consumption, in winters there might not be that much of a water consumption, etc. Okay. Now, underlying this aspect of seasonality, we also have a idea called as complex seasonality or complex seasonal effect. So, what do you mean by complex seasonality? So, we'll take up some examples. So, the first example is weekly sales during the last week of a month or during the first week of the month. Now, think of this example for a minute in your head and then try to understand as to why this seasonality would be slightly complex to analyze. Okay. So, what happens in the first week of the month? So, due to the release of all the salaries of or the income of all the people or the salaries of all the paid workers that we have in India, right. So due to the release of all the salaries, so people tend to spend more during the first week of the month, and similarly during the last week of the month, people don't tend to spend that much due to, let's say, some financial constraints and so on and so forth, right? So analyzing this kind of seasonality is slightly complex than where you see regular repetitions, for example temperature and so on, right? Or the second example is, let's say, number of trading days in a month. So different months might have different holidays or different number of holidays. So let's say, for example, October month or August month has lot of holidays, or let's say April month, right? So these are some months where the number of trading days in a month might be lesser as compared to July or as compared to September, etc., right? So analyzing any time series and considering the seasonality aspect of the number of trading days in a month, so due to every month having different trading days, so either 20 or 21 or 22 or 23, depending on the number of holidays there are in the month, this is again not an exactly regular kind of a repetition. Okay. So hopefully the idea of complex seasonality is clear, that where you cannot have exactly regular repetitions, there might be some ups and downs which are happening there. So the idea of seasonality is slightly complex as compared to something like temperature data or water consumption data, etc. Right. Now I think the next slide contains a lot of other examples where one can actually observe seasonality. So seasonality could be actually coming from different causes, right? So the first cause could be due to natural conditions. So we talked about higher water consumption during summer. So again, this is a natural condition. So due to more heat, people tend to consume more water, and naturally in winter months the people tend to not consume that much water, okay? Or let's say higher milk production during winter. So all these are due to natural conditions. Or the second idea could be due to business and administrative procedures. So what do you mean by that? So a couple of examples here. So first one is, let's say, higher traveling during summer, where you have vacations in place, etc. Or let's say higher sales during the first week of the month. So again, all these kind of tie to this business idea or administrative ideas. Okay. And lastly, obviously social and cultural behavior. So let's say gold purchase increases on Dhanteras or during that entire season of Diwali, right? Or let's say Muhurat trading on Diwali, etc. Right? So if you understand, all these examples kind of have certain underlying seasonality in place, but that seasonality could come from different sources. So either natural conditions or business related conditions, or let's say some social conditions or cultural conditions, etc. All right. So hopefully the idea of trend and seasonality is clear now. Now moving on, the next idea is cyclicality. So again, as described, the time span or the repetition span should be at least 2 years. So if you look at this sentence here, duration of these fluctuations is at least 2 years. Okay. And what do you mean by a cyclical component? So any long term variation in a time series, obviously, which is obviously longer than seasonality, which repeats in a systematic way. Okay. And one can actually describe the cyclicality in a wave shaped curve, right, in a wave shaped curve. So we saw the example of business cycle a short while back. So even there one can actually see a wave shaped kind of a curve with some peaks and some troughs, etc. Okay. And these wave shaped curves contain expansions and contractions. So if you see a peak, there will be some expansion. If you see a trough, there will be some contractions, etc. Okay. Now you see a slightly different kind of an example, which is an actual practical example which people have studied. So this example is the number of lynx. So what do you mean by lynx? So lynx is nothing but a particular species of wild cat. Okay. So the number of wild cat trapped each year in northwest Canada. Okay. And then you can see the graph in front of you. So here immediately one can make out that all these peaks are obviously of not the same length. Firstly, length meaning the height, right? So you can see that some peaks are higher, some peaks are lower, right? And also if you see the repetitions, for example, the length of the first peak to the first trough, or the length of the second peak to second trough, or third peak to third trough, are again slightly different. Okay. So again the idea is that if you see cyclicality in a time series, the repetitions need not be regular, the repetitions are irregular, where the peaks are slightly higher somewhere or slightly lower somewhere, right? And also the difference between the peak and the trough may not be of exactly the same length. Now talking about the last component, which is irregular component. So the irregular component is also called as a random component or residual. So why residual? So residual because we described a short while back that if you try to remove all the components, let's say trend or seasonality or cyclicality from a time series, whatever remains is the residual component. Okay. So what remains after removing the seasonality and the trend component is called as the random component or the residual component. Okay. And any residual component results from any short term fluctuation. So again, just to give you the same example, so this is the example of the random component which looks like that. Okay. So one can actually observe random fluctuations. So the peaks are not of the same height, the troughs are not of the same depth, right, and the difference between the peaks and the troughs are completely random. So this is a completely random kind of a graph, right. So any irregular component or random component results from short term fluctuations. So all these fluctuations that you see here are short term, right. So there is no trend, there is no seasonality, there is no particular repetition that you see, it is completely random. Okay. So at the last, one can actually conclude by saying that in a particular time series, any such component can be dominating, right. So it can be either trend or seasonality or cyclicality, or if you do not have any of these, then which component is dominating? The answer is the fourth one, which is the residual. Okay. So I can give you some examples really quickly and then we will stop for this session. So the first one is, let us say, trend. So if you have something like that, right, so obviously TT component is dominating here, right. Now the second example could be where seasonality is dominating. So we saw the example of Norton temperature data. So there seasonality is dominating. So here you do not see any trend for that matter, right. So the component which is dominating here is ST. And then let us say the third one is a cyclical behavior. So let us say a business cycle of some sorts or something like that, right. So here you can see that you do not have regular repetitions and there is no trend. So CT component is dominating. And for a structure which looks like that, where you do not see any trend or any seasonality or any cyclicality, the random movement or the irregular component is dominating. Okay. So in a particular time series, any component may be dominating. So depending on which component is dominating in that series, it becomes really easy to kind of analyze or forecast or even model the time series in a better way. Okay. Thank you.